are what you would see as a front view. Again, all of the sides of the holes on the inside, all of that are completely parallel. So they don't
the line of sight should be parallel to the surface.
When I bring up drawings should be
now
holes.
You see the.
Now, so it's all well and good the profile of your orthographic projector behind it, what I'm referring to.
On it.
And the quick trick I can do here is bring up a piece of paper behind it.
Just put a piece of paper, two-dimensional paper, just behind of this object, three-dimensional object, and put a light on it. So the light will trace this, and it will show a replica of this image on the two-dimensional surface of the paper. And what we have to do is to just highlight
so that the shadow that's left is the profile of your orthographic projected drawing. It will be exactly the same size and proportions, because remember, this light is only fired in parallel rays. So the shadow is the absolute same size as the object here. So all we need to do now is turn the lights back on and make sure we've added in all the outlines and the changes in direction. And that would look something like this.
Right.
Now, if you want to learn
this is what we are discussing now. An object, from where you have seen, this will be projected on paper. Paper is all three-dimensional object. Whatever you have seen, surface will be projected on a two-dimensional paper. And very similar. If you change the views, this is the front view, top view, and side view. Then you can put it in a paper. Explain this to another person. But a projection method here, and that is what we are discussing now. Okay, I hope now you remember this. So the plane of projection, line of sight is what just now we have seen. So now you see there, this is the projection line, what you see in here. And the line of sight is when it is parallel and converged projection. This also we have seen it, right? So we'll go back to this one. So there are two ways of projection. This also we have discussed previously. When you keep your eyes parallel to the of those, now is the convergent one. Okay. And when you keep your eyes parallel, like LOS to this, another one is convergence of projection. That's why you'll be seeing an object very far from your eyes will become you will pick your eyes to feel that it's a smaller one. As you approach to the object closer and closer, the object will look much bigger. So this is the problem, or this is the nature of your eyesight, line of sight. So for the orthographic projection, we keep our line of sight parallel to the edges of the object, such that which is called as a parallel projection. All these things we have discussed previously. I hope you remember that. So parallel projection lines can be normal or oblique to the, what do you call it, convergence projection, line of sight. One is, I don't know why it's like this. So two parallel projection can be normal or orthogonal. So we are considering only the orthographic projection, because oblique is not, that will be normally used in cartoons and others. So we are using only orthographic projection. So we keep a parallel line of sight LOS, and we will exactly project this line in a paper, that is. So this is what we are, for this engineering drawing, we are doing it. Oblique is not at all used now. So how to view this? Imagine the projection plane first. Okay. Then the view depends on the relative orientation between an object and a plane. If you keep it parallel, so this line will be parallel, the edges will be parallel to this, and so as the surface will also be parallel to this. So all you can see is the projection of this surface and its edges. So let's see who is asking some questions. Let's. The voice is not clear. I don't know why the voice is clear. Hope you. Is it okay now? Can you hear me now? Check your voice. Okay. The connection not good. I don't know why. Is that okay now, or still should we check my connection again? Maybe it's because of the my connection, or what? I don't know. Let me check the connection. Let's see. This should not be a problem. So let's see now. If you can hear me, let me check my my mic. We should be fine now. Uh, it should be all right now. Can you hear me, or should I? Yes, just my speaker volume is okay. Set cam. Yeah, I checked my audio and video, and as far as my system is considered, the system is okay. I hope you are hearing me now. Well, are you? You hear me very well? Okay. Let me check the attendance now, and then let's go to the. Yeah, thank you. Right. I tried to correct it. Let me check the attendance first, and then we will see how does it. Okay. Okay, please answer your attendance. Today, Anas Khatim Saud Al Hamdan, Abdullah Majid Ubaidullah Al Qurairi, Abdullah Majid Ubaidullah Al Qurairi, Muhammad Abdul Khalid Abdul Yahya, Abdul Aziz Sulaiman Ubaid, Ubaid Sulaiman Ubaid Sankuf, Raid Abdul Aziz Othman Al Muzad, Usama Naif Habib Ala Al Salma, Khalid Muhammad Jabir Al Bukhairi, Jabir, Abdul Majid Zayed Asiri Al Zahrani, Ryan Ahmad Abdullah Ahmad Muhammad Al Najib, Abdul Al Anzi, Abdul Rahman Muhammad, Abdul Hadi Jalabi Thani, Hassan Jarallah Al Tuwaki, Abdullah Muhammad Al Asmari, Muhammad Mansur Nadim, Muhammad Mansur Hamid Nadim. Okay, Suhaib Ali Hussein Saleh, Sultan Saad Hamid Al Khatti, Muhammad Abdulaziz Hussein Al Mahya, Muhammad Abdulaziz Hussein Al Mahya, absent. Adnan Bisam Adnan Barashi, Badr Abdullah Omar Al Amaudi, Ziyad Abdul Salam Hamadi Al Jaddani, Asil Ali Al Zahrani, Iyad Abdulaziz Al Zahrani, Faris Al Hasan Abu Kamas, Yusuf Khani Abdullah Majid, Ahmad Salim Hasan Al Khatti, Abdulaziz Abdullah Hussein Al Marshari, Sultan Muhammad Abdul Munim Al Salami, Al Hasan Allawi Hasan Al Safi, Abdullah Ayman Hussein Kamlo, Ali Hasan Al Shahri. Okay, the absentees are Muhammad Mansur Hamid Nadim and Muhammad Abdulaziz Hussein Al Mahia. Thank you. Okay, so now let's continue the discussion now. So there are several views, like I mentioned earlier. Remember, we have done the drawing and multi-view projection in the first class itself. In fact, we have done a homework. So now this is very useful for you now. The line of sight, we have seen this orthogonal and oblique. Orthogonal means parallel, oblique is non-parallel. It's a convergence one. And how you view it, the view depends on the relative orientation between the object and your plane. If you rotate it, right, if you rotate uh, the object, then your projection also changes. And you know that, right? We already done. So if you rotate it, then you see there the projection here on the plane is changed. The same object, but when you rotate it, you will project it. So you will check this edge, all these four edges. So this surface you will be projecting it here. But when I rotate this object, I could see two surfaces. This edge is this edge, and this edge will become this edge, and the other edge is here. These three edges. So now you will be watching it, you will be seeing it, you will be observing it. On the top, however, these two lines are parallel to your eyes, so you will see a single line here. And also the same the bottom line as well. The bottom line you can see like a single line, whereas the vertical lines are generally like this. You understand? This also we have discussed it previously. And when you tilt it, then you will watch even the top three angles also, because this line now you see, this line you will see, this line, and so you can see the four this surface, you can see this now because this is tilted to another axis. And of course this surface you will see that, and the surface opposite to that or the other side, this also you can see this. So this is how the projection is depending upon the relative orientation of the object and the plane. Okay, if it is rotated, this will be different, and if you don't rotate it, it will be different either. Okay, so I hope you understand this easier. So for multi-view drawing, however, which is different, I remember that axonometric drawing, we have seen it previously on the first class itself. Axonometric and multi-view drawings, we have done some uh, exercises as well in the first class itself. So we'll see what is the axonometric. The axonometric shows a virtual 3D view of an object. So this also we have seen the projections. One is the parallel, another is convergence. This is orthogonal, and this is oblique. This is a perspective drawing. Then when you keep this parallel, orthogonal can be divided into two broad categories. Multi-view drawing, I think you have done this in the freehand sketches if you remember. This is the top view, the bottom view, and the side view. And these are the construction lines if you remember this. Also I gave you some marks for it. And axonometric means the three-dimensional view inside the pictorial view will show the three-dimensional object in a two-dimensional uh, plane or paper. And the oblique is another one, but another. Okay, so this we will do it later. Right now we'll concentrate more on the multi-view drawing. Convergence or converge projection, we do not do it. That is not for technical, technicians like us. For engineering, they are doing the perspective drawing. That's beyond the scope of our course now. So when you see the comparison of the view, this is the multi-view drawing. Multi-view drawing is accurate as size and shape. So you can accurately show the size, height, the depth, and the width. Okay, the width, depth, and height can be very accurately, but of course, you need to be trained in order to draw this. So that's why you are undergoing this particular course now. So the aim of this course is to make you to be good or to be able to draw a multi-view drawing. That's the objective of this particular course. Whereas the pictorial drawing, the orthographic projected pictorial drawings are very easy to visualize. When you see it, it's very convenient and easy to understand this rather than the multi-view drawing, because the multi-view drawing can be understood by only the engineers. The common people will not understand these views, whereas the pictorial drawing can be easily understood by the commoner. And the disadvantage is the circular hole will look like ellipse or oval shaped. Then this angle will not be shown as a right angle. It will become obtuse angle due to the orientation. This is not 90 angle. This is obtuse. Those are the tilted. I mean, view causes trouble for those. That's a disadvantage. Then perspective drawing, which is not in our curriculum, but anyway, it looks more like what your eyes perceive. This is how we see the objects due to our nature of our eyes of converge. So this is what exactly we have seen, and it's very difficult to create, and the size and shape will be distorted. In fact, I have shown you some movie file for understanding this as well. Clear? Any questions, guys? Any questions? Please let me know if you have any other questions, please. All right. So now this is what uh, your the class slides I have given to you, because we have done it previously the same, the axonometric and multi-view projection. And this one is the axonometric, and the other one is the multi-view projection, right? So when you see that, this is the axonometric and this is the multi-view projection. And the principal dimensions here is the width, depth, and height. So in a multi-view projection, you can represent it, the front view, as the width and height, right? And the adjacent view on the depth, you need one more view. So we put it as the side view where you can show the depth. Do you understand what I'm saying here? So depth can be only seen from the side view. The width can be seen only from the front view. And this surface can be seen from the top view. That's why in a multi-view drawing, we provide at least 3 minimum views: top, front, and side view. Okay, so this will give you an idea for any engineer. Trained engineers, when they see the multi-view drawing, they can visualize it to combine it together and come up with an idea. Okay, this is how this shape look like if I see it in a perspective drawing or even in the projected drawing, orthogonal projection, orthographic projection. How does it look like when you see from the multi-view drawing? They provide you at least 3 views: the front, top, and side views. Okay, right. Then this is what you have seen. When you revolve it, the front view will become top view. See now how this is an object, three-dimensional object. So when you see it from the front view and just rotate it, just make it as a front view. So you're watching it from this side. So you could see this surface and this surface, right? So this is what this surface, and this is the other surface. And the side view also the same, and so as the top view. Okay. I'm sure you have done this before for your freehand sketch. These are the construction lines. They should match with the top view and side view. This height should be this height. because the three are representing the same object. When I see from here on the front side, this thickness or this height will be the same when I see it from here, right? So this should match, and also this height should match with this. So this height should be this height, which is of course this height. And the width, or you can say depth, is given here. This is the depth, and this is the width, and this one is the height. So this height can be h here, h will be from here, and width is here, w, and here this is the depth, d. So this is a multi-view drawing. So when you watch it, so listen very carefully. I put a transparent sheet in between your eyes and the object and try to project it wherever you see the surface and the edges. Then you can project it on the transparent. So those are the construction lines, if you see that. So this is the front. How I get this front? Just by projecting the lines or the edges from the object by keeping a transparent sheet between the eyes and the object. And I see from the side view now, right side view, then this is projected like this, and that is what I can see that. Watch it carefully. If you understand this, you will be getting a pass easily from this subject. At the top view, when you see there, to project the edges and the line. So now you see how the front view, right side view, and top view can be drawn. Okay. So this is what we call the glass box. Okay. So what I'm doing is just initially a box, a glass box, put it on the object, and then I explode this, expanded this as a bottom view, top view, front view, right side view, left side view, and rear view. There are so many, at least there'll be why. Okay. So is it clear now? The black box concept. First, let me put the object and put a glass box over it, and then just expand it in an exploded view so that the front view, right side view, top view, bottom view, left side view, and the rear view. So there will be actually 4 views, the basic views you can use it in order to represent any object. Okay, do you understand? All right. So now let's see how these features can be explained in the object. So all the edges, they are simply lines, right? When you see from this will become a line. And this represents the boundary between the two faces. So the surface, that's the edge. So for a cylindrical one, you will see the ellipse at the edge, and you will find only 2 lines. And for the spherical one, there will be no edge at all. Do you understand this? Any questions? So for a projection, all you can see is the edges. The edges are can be seen as shown in the monitor right now. For a rectangular section and a cylindrical section and a spherical section, where the spherical you don't have any that represent the boundary between faces because there are no shape. So the corners, if you see, it represents the intersection of two or more edges. So this is the corner for rectangular or square surface, whereas for the cylinder that be no corner because cylinder has a circular surface which has no corners, and so as the sphere. All right, no corner. Guys, do you understand? Any questions? Okay. So the surfaces, if you see, they are bounded by the edges. So you can see now you have different surfaces. So this is the surface bounded by the edge here, and this is another surface, and this too is another surface here. And here you have one surface and another surface. This is another surface. And for spherical, this is the surface. It's a circular surface. You can see it depends upon the orientation of what you have seen. So how to project this? So the limiting elements is the line that represents the last visible part of the curved surface. So here the limiting is for a cylindrical one, although the surface is continuous because circular surface, but when you watch it from here in the front view, you can see one line. So the cylindrical surface will look like a rectangle because this will become a circular. This is also circular, but all you can see is the edge like a line edges. And for sphere, it is simply the circular line of the surface. Any questions? All right. So now how to project this? Just now you have seen uh, the AF equal distance. So projection of lines, if you see that the projection of lines, when you see again A is on the plane AF, the other point in the same plane or same surface, and AR on the right side view, AT at the top view, and by joining A and AF, so there will be a BF here, and the AT-BT has the same distance because this is very, because when I see from the top, this is the same distance, and when I see from the side, it's all the same distance. That's what they're trying to explain here. So the line can be shown as shown here. Is that understood? Please pay attention. The true length of the point must be shown in the normal line in order to show by using the glass box concept. So AB, AR, BR, the AR, BR should be only seen from the side view, and AB cannot be because AB is a point when you see from the front view. Do you understand what I'm trying to say here? When I see from here, I cannot see this line because this line is parallel to my eyesight, LOS, line of sight. So all I can see is only the point. Although point can extend far away, all I can see is only the point. But when I see it from the side view, of course I could see the length. Do you understand what I'm saying? Any questions? Very important. It's like a telescope. If you see a telescope, this is a telescope, let's say. So when you use this telescope, when you watch it from here, you cannot see the entire length. All you can see is only this surface and maybe this surface. This length you may not see because your LOS and this length, this line is parallel. So all you can see is only the dot. That's what it shows. From the front view, you can see only AFBF, but from the side view, of course, you can see AB, which is equal to ARBR. So you can see the ARBR. The same you can see it from the top view as well. If you understand this, I think you have a pass already. You are passed to this this course. If you have any questions, please feel free to ask me now. Any questions? No questions. All right. So there's a big point. When you see the view, it's not the point. It can be an extension of the point. It can be a line. It can be a cylinder. It can be a but you cannot see the length. All you can see is just the projection here, just a dot or a square only. But it can go very far. We never know, because that's why in order to understand that, you have to check the side view. So just imagine here in front view, I can see only a dot, but it's not the dot. When I check it with the side view, it's just a ARBR, this length, and I can project it from the top view. It is ATBT. Some question being asked by the students. Let me check what it is. Okay, what's your question? Doctor, could you repeat the point, please? Could you repeat the projection? It's not clear. The voice is not clear. Okay, the voice is not clear. I cannot do anything now. I'm sure you have to check it again. Okay. So what I'm showing here now. Let me show you here. So what we are trying to show from here. So let's see. This is what it is. This is let's say a pipe. Okay, this is a pipe. So I use a glass box, so to show the front view, side view, and top view. Okay, so this is the front view. This is the side view, and this is the top view. So voice, I don't know. Guys, can you hear me or what? Why you have problem? All of you can hear me or not? So why only some people are having problems? All of you are getting yes, and only one guy got no. Then I don't know. You check your own system, because it's not my problem. Because all of you are saying okay, yes, 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 yes. Why someone will be low? It's low. Then I don't know. Maybe it's your problem. Your system has also a problem. Okay, so it's not my problem, because many of you can hear me very well. So right now, when you see from the front view, I cannot see the whole length. All I can see is only a circle, small circle. So when you draw it, first I project it here. So all I can see from the glass sheet, it's just a sheet. All I can see is just a small round. But is it a small round? No. So how can I check it? So I put another transparent sheet here. So when I extend this, let's see, I use the construction line here. So extend this line. So all I can see is I extend this line, and I can see the other uh, side view. All I can see is this length. All right, so the similar thing when I see from the top view also, I should see something like that. The point here is, without considering the side view, I cannot decide the actual size of the object. That is what I'm trying to say here. Because the same thing when I see here, it's only a small circle, but actually it's not. It's a big, what do you call it, a cylinder. So that I can represent by using the side top view. So this is this thing shows. Okay, you understand? So this is what we are watching it now. So let me get here. I will show it again. Uh, Projection of line. This is AB. Let's see. And when I see it by using a glass box, I'm using the glass box. So the front view, all I can see is only the point here, correct? I cannot see the AB continuous. All I can see is a small dot. So when I draw the front view, I can draw only the dot. But it's not actually a dot, it's a line. So what should I do? I should check the side view now. So it's already drawn the front view. And when I draw the side view, see the projection. It is AR, BR. So now I realize this is not a point. It's actually a lengthy object whose length is AR, BR. And to check further, I must use the top view. Okay, I also use the top view here. I put the glass box on the top. I projected the AB. Now this is B, AT, and BT on the top view. So now you see there, this must be of the equal length, AT, BT. So in order to visualize a particular object, I need to refer all these three views, the top view, front view, and side view, in order to visualize any component. Do you understand now? You cannot simply use one view to decide a particular size of an object. So you have to refer at least three views, the front, top, and side view, to discuss or to decide the size of an object. Any questions? Very, very important. We call it as the true length. So we see this is just a point here, and I see from the front view, but it's actually not. By referring the side view, I could see the true length here, which is confirmed from the top view, the true length. So in order to understand the component AB, I not only need the front view, but also the side and top views are equally very important for an engineer to visualize any component or any object. That's why in engineering drawing, we need at least three, minimum three views. Any questions? Clear? Right. Okay, so let's go to the next one. Okay, projection line. Now, if the projection line AB is slightly with an inclination, so what you can see, you will see a straight line here, which is not actually, which is a distorted line AB. You can see AF, BF on the front view, but the true size is AR, BR. This is also a tilted one, and in the top you could see AT, BT. All right. So when you projected it in the what do you call it? Uh, the side view and the top view, you could measure the equal length. But you can see this is depends upon the orientation of the particular line. For the front view, it is slightly tilted, so you cannot see the entire exact length or equal length. You can check it only from the side view and top view as well. Do you understand what I'm saying here? So again, you should be very careful with the projection of the lines, how it will distort when you use the multi-view drawing. So the point here is you cannot visualize a product or an object by watching only one view, but you at least need three views to decide a particular size and shape of an object. So that is the true length, foreshortened, and foreshortened. So only you can see from the top view, which is parallel to this one, so you can measure the actual length from here. Do you understand? Okay, now if it is inclined to the front view like this, AB is this orientation, the rotation is with the what do you call it, in the y-axis. Okay, now what could happen? You could see a distorted top view and distorted front view. Only the side view give you the true length. You can see that. When I see the front view AB, so this is projected to the front view like this, AF, BF. It's not the actual size. And BR and AR, which must be the true length of this. And when you watch it from the top view, this will be again distorted. So the equal length can be only seen from the side and to some extent maybe from the top, but not from the front view. That is for sure. You understand? Any questions? Come on. If you have any questions, feel free to ask me. All right. So these two are foreshortened. So this we call it as an oblique line. That's why for drawing any multi-view drawing, you must keep the parallel, what do you call it, LOS. The line of sight should be parallel to the edge. Otherwise, you will get all these problems. Oblique line or the foreshortened line only. You can see that. So this will give you, a very distorted figure about the particular object. So the projection planes, just imagine this is a triangle ABC. When you see it from the front view, side view, and top view by using the glass box concept, right? So when you use the glass box concept, the triangle looks like a line when you see it from the front view. So a triangle ABC, the side AB look like a single line BF AF, as you see there. So AF and BF will look like a simple line because A and C are in the same orientation, which is parallel to your eyes, so you cannot see that edge. All you can see is only a small line BF AF in the front view. Whereas in the top view, of course, you can see the triangle, and the side view also you will see only the line. Do you understand what I'm trying to say here? So when I see it from here, I can see only this line from this side, and also this line only. But only in this view I can see the surface. So I need the front view to see the original uh, size of the size and shape of the object. So in the front view I can see only BFAF, and the side view I can see only ASCS. Correct? So this will be, let's say, right side views, they put ER, BR, which are same parallel lines on the same plane. So all you can see only a point there, but I can see only a line that represent AC. So this is AR or BR, ARCR or BRC, something like that. But when I see the top view, of course, I could see the entire true size of the triangle, such that the CTAT is the equal length of ERCR. Okay, you understand? All right. So the time is now in my watch. It is 5:55. So please go for a break. I know this is uh, quite. Maybe if you and we'll come back after 10 minutes. Okay. All right. Please go for a break. We'll see after this. Okay. Okay. You can go for a break. What about the left side? Repeat it, please. Repeat it. We'll see later. All right, so I hope everybody is in now after the prayer. So can we start now? Let's see, there were some questions asked by the students here. Guys, you can hear me? Is everybody in? Right, so there have been some questions being asked. What about the left side view? Repeat, please. So, yes, there are two. I told you there are 6 possible views: the top view, front views, right side view, left side view, rear view. So, 6 views possible. But you see there, yeah. So, what's the question, please? Can you?
Yes, I have 2 questions actually.
Yes.
The first project, you said rear view. Why we draw the line cutting?
I'm sorry. Again, can you explain?
First project, you saw it.
First project? What do you mean by first project?
Yes, yes.
What project it is?
Can you go back to the slides?
Wait, just a second. Let me see. Let's see. Okay. This one here, yes. Which one you're saying? Is this one?
No, no. I think it's previous one.
This one? Okay. Yes. So when you see the point here, A, what's your question?
No, not this. Not this projection.
Mm-hmm.
It's like the first freehand sketching. Maybe it's. Let's go back.
Which one? What's your? This one? Because this was.
I have a question right here, and yes.
Yeah, what's
why we can draw the box of glass into A?
Wait. Okay, this is your question, right? A, B, C. This is
BC.
Right? Yes. So when I put the glass box as this BA is parallel to the front view, all I can see is only the BA line. I cannot see the entire surface. You know that? Because you are watching it with your eyes parallel to these edges. So all you can see is only this edge, not the entire surface. You understand what I'm saying? You can see only this line. Behind this thing you cannot, because just imagine in front of you, just take a pen and keep the pen in front of your eyes, parallel to your eyes. You cannot see the full length of the pen. All you can see is the ball point, the point and a circular section only. You cannot see the length of this pen. Then the pen is parallel to your eyes. Right?
Yes, but my question was why we can't draw a line from B to C in the glass box.
In the B to C glass box, yeah, in the glass box you can, but now we are discussing only the multi-view drawing. Only the multi-view drawing. We are not drawing the 3-dimension now. We are drawing only the 2 dimensions. You understand?
Okay.
Because there are 2 views. You remember, you can express this in 2 different ways. One is, as I told you, the isometric view. Like, if I want to show it, I can draw. Let's say, where is it? Draw this. Okay. What I do, I can draw an object like this, a 3-dimensional object in a 2-dimensional paper. This is also okay. But what we are trying to show it here is, we are using the multi-view drawing in order to show this, because of the fact that this view can be changeable, depends upon the way you see. If it's an orthographic projection, it will be different. If it's an oblique projection, it will be different. You see, suppose if you keep your eyes too close, you cannot see the entire thing. You can see only this surface. When you keep your eyes somewhat far away, it looks very small. If you go nearer and nearer, it looks bigger. So your eyes cannot show the actual size. You understand my point? That's the limitation of your eyes. You understand? I think I have shown you a movie last time about this. I don't know whether you attend the class or not. This is the problem with your eyes. So when you see this, okay, now you see here. This is a lobby of a hotel, and when you see it from here, this is not the actual size. As you see on the corner, this is very small, but it's actually not. It's the limitation of your eye. So when you draw this, it's not showing the actual size and shape of the building. It shows how you see it, which is not correct technically. You understand what I'm saying? So what I'm going to do, I have to make the multi-view drawing to show the correct size and shape. You understand? So this is the limitation of your eyes. When you get closer, you can see the edges. And the problem with your eyes is if the object is far away from your eyes, all you can see is a very small object of this. So that's why the projection, when you project it, it depends on the way how you see, depends on the orientation. So for engineering drawing, we take a view that such that the surface and the edges is parallel to your eyes, and then we use the multi-view drawing in order to explain the shape and size of the object. That is the idea. You understand what I'm saying here? So this is what I said the problem here is. Uh, yeah, you've seen this, right? I think we have shown it. See, the problem here, it depends on the eyesight. When you keep your eye parallel, you will get the same size. But if you see a convergence projection, that means if the object is very far from your eyes, then it looks smaller. You cannot see the actual size and shape. Okay, so that's why we are using the orthogonal, which is parallel, and not the oblique. Oblique is totally different. So oblique, we are not using it. You understand? So here there are several methods of projection. One is with parallel projection or with converging projection. The parallel projection, you have an orthogonal projection, oblique projection. And in the orthogonal, you have multi-view and axonometric view. And here we are using the multi-view drawing. The axonometric is also good, but this is not very accurate because it depends on the way you look at it. There's a limitation of human eye. For instance, if I have a circular section here, okay, the circular section, when I see it here, it will not look like a circular. It looks like an ellipse. You understand what I'm saying? So it does not show the actual size. But when you use the multi-view drawing, of course, it will be circular. So you will get the exact shape and size by using the multi-view drawing. Do you understand? If I use the axonometric or even oblique, it does not look like a round. It looks like a ellipse. You understand? Come on, speak
Yes,
out.
yes.
So that's why, although pictorial drawing will give you a very clear-cut, very nice view visualization, but it will not show you the exact shape and size because of our the limitation of our eye. So that's why we are, for the technical drawing for engineering purpose, we are using the multi-view drawing. It will give you, we simply keep your eyes parallel to this. Exactly whatever you see, you draw it here. Then for an engineer to visualize it, he has to check these 3 drawings minimum. Of course, you have 6 views. You remember that there are 6 views possible, but maximum 3 views are okay. You know why? The top view and bottom view is the same. The right side view and the left side view, most of the time, if it is symmetric, it is the same. So in order to keep the views minimum, we normally keep at least minimum 3 views. Maximum, you can have number of views. I told you in the first class, I have 675 views for a particular drawing when I was in industry. So you can have as many views as possible. But minimum, at least you need 3 views in order to explain the shape and size, because when I see it from this side, I can see only the round, but the length can be seen only from the side view. I hope you understand that now. Correct? All right. Any other questions, please? Okay, good. Any other
In the
questions?
slide, I think in the previous slides, not this.
Okay, what's your question now?
I saw. Go back to the next previous slide, not this slide. The one you explaining the points.
Right.
Yes. Slide number 12.
Slide number 12. Okay.
Yes, here.
Yes. What is this? What's your problem? This we not explained it until now.
Yes.
Okay. All right.
When you said that the rear view, you draw the line or cutting line.
Okay.
Why we draw it like that?
Why we draw line cut like this?
Yes, from the back, I mean.
Okay. Well, I don't understand your question. This is the object, all right? So this is a three-dimensional view of the object. I want to show it in a two-dimensional drawing. So what I'm going to do, I see the front view, right? So the front view, when I see it from here, keeping my parallel to my eyes, these edges will be parallel to me, my eyes. So all I can see this surface, correct? This edges I can see. This surface I cannot because this is parallel to my eyes. And this surface only I can see. This edge I can see, and this edge. This surface I cannot because this is parallel to my eyes. So all I can see is a view like this. This is what I can see. This is the first surface, I can see that. This is the other surface, I can see that. That's it. But this is not the shape. So what I should do, I have to take the left side view. So left side view will look like this. And I know, okay, now I know of when I see it from the front side, it is like that. And when I combine it with the left side view, I can see, okay, this should be like this. And when I see the top view, the both will be same. When I see from the top view, I can see this surface, yes, but this surface I cannot because it's parallel to my eyes. And this surface I can see. So when I see it from the top view, I by using the construction line, I can see the top surface, this one, and this surface.
Okay, the red view.
Okay.
It's
so now
will be a rectangle.
All right. Now, if I see the front view, right side view, top view, what about the other view? What view you are asking on the?
Red, the behind.
Back view, rear view.
Yes.
Right? So rear view is simply a square. That's it. Because I cannot see this surface on the other side. Just imagine you are seeing from this side. All I can see is only this surface.
In the slides, they draw it with the cutting line. Yes.
So
like
this line is there, right?
Yes.
What is this line? Because even though I see it from the other side, I want to show there is this edge is hidden here. Okay, so this line I cannot see it, but it exists. So I said this line is hidden from my view, and I draw it here. But you don't need the rear view. If you see from the front view, you already know there's a surface here. So why you need the rear view?
So if I will
that's why I said unless otherwise asked, you don't need to draw the rear view. If at all you need a rear view, you can draw it. I told you can draw any number of views if it is necessary. Unless necessary, you don't need to draw. So front view, top view, right side view, left side view, rear view, and bottom view. There are at least 6 views are there. But for most of the components, the front view and side view, in order to check the width, length, and height. If you need the rear view, you can draw it. But will that helpful? Nothing, because you cannot see this surface from the rear view. So unless otherwise necessary, you don't need to draw all the views. Understand?
Okay. Yes.
If you can explain this object to another engineer by using the 3 views, a minimum 2 views, if you can, also you can use only 2 views. Just imagine, okay, that's one more thing. Suppose this is the object. How many views you need this? All the time, just you see the front view is square, top view is square, side view is square. Good enough. That's it. You need a for bottom view, side view, right side view, left side view. Do you need that? It's not, because it's symmetric. Wherever you see, it is simply the square. So simply draw 3 views. Good enough.
Okay.
Or not?
Yes.
So that's why it's up to you. How many views do you need? Keep the views minimum, because otherwise people will get confused. Why? They keep so many views? So if you can explain another engineer by using minimum 3 views, good enough. But still you are not satisfied. You have something hidden here or something you want to show. You can make n number of views, no problem. But the other engineer will see, oh, this guy is not a very clever engineer. Why he unnecessarily provide this many views? Suppose one engineer shows this left side view, bottom view, top view, then you will laugh at him. Why you provide this? Unnecessary. Why? Because top and bottom view are the same. It's a waste of time, waste of paper, and waste of energy. You understand that?
Yes. Yes.
Okay, good. I hope everyone understand now. Thanks for asking questions like this. That will help a lot for the rest to know this. Okay. So let me show you one more. I think. Okay. Let's go back to. This is not much time. So now you see why you see the line, and how the line orientation will change the projection here. And we show with a triangle. So the triangle can be shown only a line from the front view, another line from the side view, but the shape can be seen only from the top view with its true size. So what is more important to know here? At least you need 3 different views: the front view, top view, side view, in order to show at least one side will give you the true size. Then the rest of the other 2 sizes do not or does not give the true size. So at least you need minimum 3 views to explain any shape. At the same time, you can use n number of views in order to explain if at all necessary. Because at least you can have 6 views minimum: front view, rear view, top view, bottom view, right side view, left side view. All right. So, but minimum 3 views will be good enough, so long your product can be, or the object can be explained with its size and shape in a true size. Now, the projection plan, if it varies, now how it looks like. It looks very weird. If the angle of this orientation is changed a little bit, now you see that this will not show you the actual size. The true size will not be shown. Okay, CF, BF, AF. This is the front view, and on the side view you can see only a line, CR, AR, BR. And in the top also you will see another what do you call it, the shortened projection of this triangle. So now, because of this orientation, uh, those 2 views will not give you the actual size. Okay, only the edge will give you the length, but still the other 2 is not giving. So what you can see, the width is true size, the height is true size, whereas the other size is not true. That's why the orientation is very, very important to keep it parallel to your eyes in order to show the true size of any object. So for an inclined plane, it will not give you the true size as you see from here. So if it is oriented, the orientation is slightly vary with the uh, the projection here. So now you see how it changes. So again, the front view and side view are foreshortened, and the equal length only you can show it with an oblique plane. So why we are providing all this? Just to make sure that you have to keep a parallel edges with your LOS, the line a good. Otherwise, if the orientation is slightly changed, the size and shape will not represent properly. So now you see here. Now how we can view this projection of object, how you can obtain the views by projecting all the features to the picture plane. So now you see this is the component of the object. And you can have front view. All right, this is the front view, and this is the side view, which is minimum required, and the top view. When you see from the front view, all you can see is only the surface and the edges. Side view, only this surface and these edges. And what you cannot see from this side, all you can see, this looks like solid, but it's not. Actually, it has some provisions or some feature which is not visible from the front view. In this case, how we can represent it. Okay, that's the next what do you call it, objective of this. So first I see the red and I project it here with its length, true length and true height. And then next, this is shown. The side view can be shown by projecting the construction line here. It's very important. You don't need to measure everything here. First you measure this line, then just project this to the side view because that is the true size. And also project these lines to the top view. You don't need to do it again because you already done the front view. Now the side view is drawn and the top view. So after watching this, now you know when I see from the front view, it looks like a solid. And when I see the side view also, it looks like a solid. But when I see from the top view, it's not solid actually. So now you have to visualize, okay, by watching the this multi-view drawing, you have to visualize how this would look like. You understand? Any questions? Now, if this is hid, when you see from the front view, actually this inner square, inner rectangle is invisible. So what I should do normally, I will project this from the top view. So I draw a construction line here, and then I project it here as this is the hidden projection here. So when I see this dotted line means I am trying to represent there is something what do you call it hidden. So I have to see the top view and then comparing these two, then I can visualize, okay, there is a projection like this and this is what this hidden line shows. And side view also, then what I do, I project this line, okay, then I draw a 45-degree angle and then project back here and then I draw this line. So now I see the front view, I can identify the, okay, I can see actually a solid surface, but there is something hidden here. Then I compare this with the top view, okay, there will be a rectangular section hidden and which is shown here. And the side view, yes, these two edges are hidden, so that edge is here. And this surface is what it is shown here. So this is the way you can represent those hidden edges. Okay. So this hidden edges, you see, this red color edge is now shown with the hidden line, and the other surface is shown from the other line. Similarly, you have to project the remaining surface which are invisible too. Any questions? Guys? Okay. So I repeat again, just watch it carefully. I'm trying to show you a three-dimensional object like this. So first I draw the front view, measuring the length and height of this object and draw it in a paper. And then I use in the construction line, the side view is drawn. And then from the top view, I can draw. So now this is drawn. After that, I want to show the hidden surfaces and edges. So the hidden surface is first this red color view. So I draw it with a hidden line because I cannot see it from the front view, but it is hidden inside, and it starts from this to all the way. So it starts from the top all the way to, and then the other surface is also shown here in a hidden line because in the front view I cannot see it, and also in the side view I cannot see, it is hidden. So in order to show the hidden surfaces, I show with the dotted line like this. Any questions on this now? Okay, right. So you have to project the remaining surfaces which are invisible too. Now the projection of object from this. So how to draw this? Again, you see from the front view, I can see the surface here, the color, and the other surface, a semicircular one. I use the construction line, extend it all the way to the top view, so that I don't need to measure the width again because already I draw the length. And then in the top view, all I can see the S, and then this is already drawn, this surface. So surface rectangular drawn, and from the side it looks like a line like this. You see from the sides view. Okay, this is the top view, the red color one. Now it looks like a rectangle from the top, and when I see from the side view, it looks like a inverted L. Any questions? Do you understand? Have any questions? Please feel free to ask me. So I repeat again. This is the front view. This is the side view, and here is the top view. So I'm watching it from right from the beginning. Front view, I can see this rectangular surface, and then the semicircular surface, and I see it from the front view. Yes, this top view, I measure this and made the rectangle, and then on the side view the S will be marked because by projecting these lines, the same S I can see it from the side view, and I can explain this from here by a simple L. All right. Okay. Let's see. I'll be a question. Let's see what question is asked. Yes. Pray time. You can pray. Already I gave you time, and those who want you can. But the rest you remaining here because we cannot. I already gave you the time, right? All right. Okay. So please continue. Shall we continue discussion or what? It's 6:40. Yeah, this is the time. Just now I gave you. Okay, go for prayer, and after that there will be no break. Is that okay? All of you? Please answer me. Okay, go for a prayer and come back. There will be no more break. The second break will be cancelled now. This break you can use it. Please. Okay, come after prayer. Thank you very much. We will see after the break. There will be no more break anymore. Okay, everyone, please go for the prayer and come back. Then I will continue our discussion. Thank you. Okay, so shall we start? Everybody's back. Or still you need some more time? Anybody's in? Okay, let's wait for another 5 minutes. Okay, hope you are back. Everyone in? Still, can you hear? I think we can start now because this is a very important and the most important part of your subject. So all of you can understand this better. And Nadim, this time today I'm giving you the present, no problem. Next time, please don't do that. Okay, next time I will check because I give you a color. So I'll check your presence again. So be careful. All right, so let's continue our discussion now. Let me show you what we're seeing. Okay, so let me repeat. This is how you project the circular section. Because circular section or semicircular section, when you see it from front view, it looks different. I mean, the true size you can, but when you see from the top, uh, it looks like a rectangular section, as you see from here. The semicircle is retained, but when you see from the top, the S, the section S, the length S is there, and you will see uh, it looks as if like L shape, an inverted L on your on the right side view, and the top view looks like two different uh, typical rectangular section. So for this case, you have to visualize yourself by watching it, the front, top, and side view together, and you visualize the original shape of this. So this is the most important part, and of course the most difficult part for any engineer to visualize the actual object by watching the multi-dimensional, multi-view particular. So now if the the object is slightly different like this. So as you can see, first you could see from the front view. Now this is the front view, and I can see this surface which is shown here. This is the surface I can see, and from this surface I know the length of this from here, and the height also I know, but the width I may not know. So in order to know the width, I have to go for the side view. So what I do, I project these lines, I can construction lines, and extend this construction all the way. I will draw. The next one I can see from the side is this. So now I know the width also, or you can say the depth. Already I know, and this is the height. So this is the length, depth, and all right. So this is the height. And when I see from the top view, it looks like this, but this is not complete because I can see this edge as well, or not. So how this could change like this. So this is there, and finally, the red part is shown here. So the most important point here, you should remember, this small section will not be shown in the right side view, parallel to your eyes. So now what you have to do, you have to visualize it by watching the front view. So in the front view, there's a gap here, and in the top view, it looks like that. So you coordinate all these three views together, and you imagine yourself and visualize it, and then you have to draw, or you have to identify, or the true size of an object. You understand? Any questions? I repeat again. This is the object, I see from the front view, rectangular section H, L. I don't know D. So for the depth, I have to use the side view. So the depth is given here. And when I see from the top view, all I can see is this color. And then semicircle is projected to the top view like this. And in the side view, you can see it looks like this, different. And the problem now here is the only difference, not problem. For the engineers to visualize the object by coordinating all three views together, not by a single view. So anything, if you want to visualize it, you have to refer all the three views together. Okay, so this is the final view of the object. Okay, so now this is what we have discussed in this today's chapter 3. I'm going to give you some exercise for today, and you have to start right now. Then you submit it for the next class. The dimension for very simple views, I'm going to give you. Let's see what we can do it here. All right. Okay, transferring the depth. Some of the examples. Okay, line convention, all these things are there. Right now, we just use the freehand sketch. Okay, we just use the freehand sketch for this one. Let's see some. So let's see how we can do this now. Edge surface limit. I don't know what's okay. This is 7 if you click it or something like that. But you cannot use it since. Let me see what can I give it to you today. Right. So please take your sheets now, the A3 sheet, and let me show you some objects so you can draw the freehand sketches by using the dimensions. Last time you have done with freehand, right? So today we will try to draw some standard objects. So certain dimension. So let's use this same with this is given here. I don't know. Let's see the book is given or not. It's not given. Okay. Let me check the book. The book. There is some. I already gave you the book, if you remember. So, okay. Let's see the book. Anything you can do it today? Okay. In the let's see. Now, okay, if you take the book, I already uploaded the book in your Blackboard. So if you see in the books, the page number 18, please everyone. The first exercise, 1.3, line used in an orthographic projection. So how to draw these lines? When you see it from the front view, top view, side view. So you have to fill this, or you have to draw this. Let's see how you can draw. Is there any exercise? Okay. It is there. I don't know whether you can do it now, but I hope you can. Let's there. The front side, top view, and side. Okay, please do this. Missing lines. This one. Okay, this is orthographic position. Okay. All right. So please, with any scale, with certain scale now, how to create the projections? There are several exercises given here, and maybe we can try one or two exercises as a class exercise now, so that everyone can understand this. Okay. Can you all see, right? So let's start for the time being. This one is very easy. We will see today now. Okay, I think this is easier. So now, okay, let's take this exercise. Oh, now you see there. This is the, we call it. Let's see this. Okay. Now, if you watch it here, this is the actual object. This is the object here. And in the object, if you see the front view, so when you see it from here, this is the section. You can see this surface. This is the surface here. It's shown. And the circle, which is on the top view, which cannot be seen from the front view. So what I did, I draw the center axis and then use the hidden line here. So when I see from the front view, I know there is a circle because of the center line. And when I measure this length, this should be the diameter of this circle. Then I use the construction line to project it all the way, each of this. Then I draw from the top view. I can see what is there. I can see this surface. So this is the surface I can see. And of course, I can see this circle. So I make the center and draw the circle. Then from here, I make a 45-degree angle line. And then I just put the construction line, which hits the 45-degree angle, pull it down. So this length will be the same here. So I don't need to again measure this all over again. So when I see from the right side view, all I can see is only this surface. This is the surface. However, this surface is hidden. So that surface is given here as a dotted line. And of course, this circle also hidden. So the circle is made by using the dotted line and a center line. So this is how you have to draw the multi-view drawing here. So the next one is, let's try today at least one exercise so that everyone will try. They will get 1 or 2 marks today. So please try this first. Okay. Class student exercise 1.4 missing lines. Okay. So this is your today's exercise. Let's see. All right. So here you write your name and then use the sheet and draw those. So, okay, give it a try first. Let's see. Okay, with any scale, first draw this and fill those hidden lines. Fill in the missing lines in the front side, right side, and top views. The front view has one missing visible. The right view has one missing visible line, and the two missing hidden lines. So this is your class exercise now. Draw the missing line now. You take the book. The page number is 117, and this is your exercise today. Later, I'll give you a homework. I will send it by email. Okay, tonight, maybe tomorrow. So right now, please everyone take this exercise. And before that, maybe it's a little difficult. Maybe I'll give you a very small exercise. Let's see how you can do that. Okay. I still think this could be a little difficult for you guys. Let me see how we can do that. Okay. Let's see. Okay. So first, let's try this first. So we'll try now. So just top view and all right. So this is as an object, okay, and the length. You can say that this length should be 100, and this should be 60. The height is 40, but also 40. Okay. And this is 40, and this length should be 50. Okay, so check everyone. This is your classwork now. Draw the front view, top view, and right side view. Okay, now okay, start now. Just visualize yourself. How does it look like from the front view? So the front view is here. This is the front view. This is the side view, and this is the top view. And since the dimension is given, it's not a freehand sketch. You have to draw with the dimension. Okay. So first, what you should do now, draw a line. Watch it carefully now, guys, please. First, take your A3 sheet, draw the margins, write your nameplate. Later, you can do that when you submit the assignment. First, what you have to do, make the A3 sheet to 4, you divided it to 4, and in the first, let's say, in one of this division, just first draw the line here. Okay, first draw the line, and then this is the front view, and this is top view, and the other one is side view. So now how to draw this, I will give you an idea. So what you have to do first, by using a 2S pencil, draw this section first. So all you can see this section is this section. the first rectangular section, you can see 60 to 40, 60 mm length, 40 mm height. And then you can see one more surface here. So this will extend this, and you can see again this will be 40 and 60. And then just extend these lines, okay, and also project this line because there's a construction line. These are the construction line, and from here, from the corner, you draw a 45-degree angle. Okay, this is 45-degree. So now what you do, from the top view, you can see this rectangle here, another rectangle on top, and you project it on and project these lines. Okay, here, and then using this, you can draw the original. This is the one. So this is the original size of this. And then here, you can draw it. This is the length here, and you can see this. All right. So this is front view, right side view, and top view. Please give it a try now. I'm going to send you one more assignment tonight. So these two you have to submit it by next class. This will carry you 2 grades, and it's not freehand sketch as you see. Be dimensions. Right now, start. If you have any questions, you can ask. Meanwhile, this your time starts now. Everyone. Okay. No freehand dimensions given. So why freehand? Dimensions are given. So use the dimension. 60 mm, 100 mm. So it's not. Yeah, submit the next class. Not now. You have to start now because I'm going to send one more drawing. So let me see. If you have any questions, you feel free to ask me now. So everyone, open your mini drafter and start doing it now. Yeah, it's going to be 2 grades for each drawing. It's very simple. Later we will see the way how you draw. Then I can increase the grade now. But just try, give it a try. This is a class exercise. Try to do it. Read the question. First view, second view, third view, front view, top view, and side view, right side view. Understand? Who asked me how many views? This guy? Huh? What do you observe the class or what? Start now. If you have any questions, ask me. Okay, good. No problem. I'm just joking. Don't worry. All right. No problem. Start doing it now. I might increase the grades. Maybe if it is too difficult, I might increase the grade because there's a trick. There's a difficulty. Little difficulty is there. I don't know when you will know. A small twist in the question paper. So just check it. When you start doing it, you will know. First, try the front view. Then draw the blue color lines, construction lines, and then you will. So more. Everyone, watch it very close. You understand? Are you here with me? For those who still have some doubt, please watch again. So the question here given is draw the front view, top view, and side view, right side view of this given object. So what you should do first, take your A3 sheet and put the margin, divide it to 4 equal parts, and in one of the part you draw it because it's a very small component, so it's be easier for you. So first thing what you have to do, now listen very carefully. Wait. I will draw that. So first you take the what do you call it? In this, first you draw a line here. Okay, first you draw the common line. Okay, and then you check the drawing. If the front view, this is the front view, so I can see the 60 by 40 rectangle first. So first draw a line of 60. So I draw a line here. This is 60 mm. This will be 60 millimeters. So don't draw the millimeters here because all the what do you call it? The dimensions are in mm. So you simply don't write the millimeters. It's just 60. So now take the line or the corner, and this should be 40. So you draw this 40 here and join it here. Okay. So this is 60 by 40. I made the rectangle first. Then the next thing is I can see another rectangle when I see from the front view, 60 40. Again, I will extend this to 40. Okay, so it's going to be the same. This is 40, 60 by 40, and I will join it this here. So this is what my front view. So since I am using the two H pencil, so this is 60, this is 40. So I will extend this line here and make it like this and draw this line like this now. This is 60. I don't need to write millimeters. It's already there. So I just draw very similar to this. So 60 by 40, and this is also 40. And then this is 60 as the same. So now what I have to do, I have to make this by using a HB pencil. Okay. Then I draw this with the true, and so what I'm going to do is to make it original one by using the I cannot draw vertical line because of my electronic pen. So you don't draw like this, okay? If you draw like this, you'll be in trouble. Just use the scale and draw a vertical line. So this is my front view is done. So the next thing what I just do, I'll go again by using this line, by using the construction line. Or so what I do now, I will extend these lines to the side view. So I extend this line all the way. Here also I'm extending this line all the way from here. And very similarly, on the vertical line also, I extend this line all the way here. So this also, I'm extending this line here. Okay. So now if I draw it here, this is my line. So I'm extending this all the way, and this also here. Okay, so I do this. So I extend these lines all the way. These are the construction line. Okay, and the most important thing here is just from this corner, you just draw a line, 45-degree line. So this should be 45. And then now you draw the top view because you already know the projected lines. So you can draw the top view. Okay, the top view will be like this. So if the top view, I can draw the first, this one. This is the line 60, and this is my another line. Please, this gap is actually the projected line. So my projected line is slightly inclined, so don't. This is the line actually. So let me cancel this. Otherwise, will be. You understand what I'm saying here? These are the projected lines actually. Huh? Okay. So this also, when I see from the top, this is 100. Okay. This is 40. This is 50. So this should be 50. And then there'll be. I'll extend this. So the total is 100. So I draw the 100 mm first, and then from the 100, this is 40, right? So I could see the 40 here, and then I try to extend this here, and I join it there. Because here it is 50, 40, there is a 10 mm inclination is there. That's why you will find 3 rectangles on the top. You understand, any one of you, all of you, right? Right? So then I extend this, then I'll project it here. Project it there. It's not very clean, but that's how I project it. Okay. So when I project it, then in the side view, this is the first one, second one, third one, and this will I join it here, and this should be like this. So I hope, is that okay, all of you? Right? Any questions? So if I see it from here, this should be 100, and the height should be 40 plus 40, 80. And this should be 40. You can say this is 40 again. This is 40. And this is also, this is 50. This is 50. So 50 plus 40, 90. This should be 10. So the total 100 will be here. Okay. So here you can see this is 40. And this is 50. So not exactly like this, but something similar to this. Okay. I hope you have some idea now. see what people are asking me. Any questions? Okay. Clear, clear, clear. Yes, 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 clear, clear now. I have to be like this order. I have to draw the 3D. No need to draw the 3D, please. No need to draw the 3D, only 2D, please. Do you understand? No need to draw 3D. 3D, no. 2D, yes. Now continue the drawing. Let me see how many of you can finish it today. Then I might give you some uh, bonus marks if you can finish it today. But I don't know. It's okay. It's okay. I don't need to finish it now because time is already 7:32. So this is your first classwork. So please draw it in a paper of something. Otherwise, you will miss it. Or you can check the recorded view also. And then I will send one more homework tonight or tomorrow. So you will do it, submit it by next class. Okay. All right, doctor, do we have to write the blue lines? Absolutely, you have to draw the lines. By using the blue lines, must be using a 2H pencil, and the thick line should be HB pencil. Please, yes, very, very important. All of these projection lines or the construction lines are very important. You know why? You don't need to measure again. See, you just project it. You already see. You just project it. The 60 is already there on the top. And if you project the side view, 80 is already there. So you don't worry about this. Otherwise, every time you have to measure it. You understand? So draw the construction lines. Very important. So construction lines, these lines you should use 2H, and this should be HB. Understand? So this will be HB pencil. This is 2H. I want you everyone to draw these lines, and this should be 45-degree angle. Don't forget it. This is 45. So once you do the 45, the same length will be there, so you don't need to worry. So let me see how many of you can do this. All right, guys, please answer your attendance again. I want to see how many of you are here. Before you go for the, do we need to make the margins? Absolutely, without margin, don't draw. Okay, we submit both or only the homework. I'm sending you one more homework, so submit both together. You understand? Wait for an assignment and then include this. So you will be submitting two homework next time as an assignment. All right. Okay. So please answer your attendance again. Let me see how many of you are still here. Anas Khatim Saud Alhamdan, Abdullah Majid Obaidullah Al Khurairi. Abdullah, you are here still. Can you say yes or no to me? Say hello, please. Abdullah Majid, say hello. I want to hear you.
Yes.
You are here still. Very good. Welcome. Okay. Muhammad Abdul Khalik Abdullah Yahya. Here or not? Say yes or no, please. Muhammad, are you here? Not here. Muhammad Abdul Khalik Abdullah Yahya. You're not here. Abdul Aziz Sulaiman Obay Sankuf. Obay Sulaiman Obay Sankuf. Raid Abdul Aziz Uthman Al Muzal. Osama Naif Habib Ala. Khalid Muhammad Al Buhairi. Abdul Majid Al Zairani. Ryan Ahmad Aziz. Ahmad Muhammad Al Najibi. Abdul Rahman Muhammad Al Nanzi. Abdul Hadi Jallawi. Hassan Jarallah Al Tuwaiki. Abdullah Al Asmari. Muhammad Hamid Nadim. The guy who was late today, Muhammad Nadim. I will check until next week, next class also. Careful. Suhaib Saleh. Sultan Al Hatti. Muhammad Al Mahia. Muhammad Abdul Aziz Al Mahia absent. Okay. Adnan Barashi. Madar Al-Lamaudi, Ziyad Al-Jadani, Asil Al-Zarani, Asil Ali Al-Zarani, Yad Abdulaziz Al-Zarani, Faris Ali Abu Kamas, Yusuf Abdullah Majid, Yusuf Ahmad Al-Kharti, Ahmad Salim Hassan Al-Kharti, Abdulaziz Al-Masri, Sultan Al-Salami, Al-Hassan Al-Safi, Abdullah Hussein Komlu, Abdullah Ayman Hussein Komlu, Ali Hassan Al-Shahri. Okay, so only one guy is cheating, eh? Muhammad Abdul Khalik Abdullah Yahya. I will mark this guy. Initially, he came to the class and he left it, eh? This guy is a cheater. This guy is a cheater. Huh? I'll give him an absent today and ask him to meet me next class. Okay? I will give him a mark here. Abdullah Majid. No, not. Muhammad Abdul Khalik. Muhammad Abdul Khalik. I give him a yellow mark here. Let me check whether he attending next class. He's a cheater. Huh? So let me put him as a cheater for today's class. Since today is absent. Let's see. Okay, guys. Hope everybody is doing well. Continue your work. If you have any doubts, please feel free to ask me now. So Muhammad Abdul Khalik is today is absent to me, and the other guy is let me see who is the other guy. Muhammad Abdul Aziz Al Mahia, 759. Wait, 759. Okay, he is absent. The rest all are present today. Going. All right. Okay, so today is 12th, and I hope the guy came back or what? Let me see. Can you go back, doctor? Where to go back? Yes, present. Who is this guy? Yahya, you are here? Who is this guy? Yes, present. Who is this? So, Muhammad Abdul Khalik Abdullah Yahya, you are absent. Are you here still or not? So, you are absent to me. All right. Because I want you to present entire class. Then only you will understand. See how difficult the drawings are. And if you don't attend the class, how can you finish it? Huh? All right, continue. If you have any doubts, please feel free to ask me. Yes. Anybody? Still this guy is there around? Let me see. Can we draw the lines of measurements by freehand? No. Now no freehand at all. No freehand. For the exercise, no freehand anymore. So yeah, maybe I assume you are asking about the what do you call it, the arrow lines. That is okay. When you draw the arrow line, please everyone watch it carefully. So if you draw the arrow line, there are several arrow lines. You know that, right? So the arrow line for the engineering drawing is like this. So it will be, this is the arrow line for engineering. You should not draw like this. Wrong. You should not draw like this is all. So this is the correct one. So remember, you have to draw this here like this. It should be sharper. So first use your scale, and only this head of this arrow should be like this. You completely fill it. So this is the engineering what do you call it, the arrow. So I repeat again. So this should be like this. Okay, later we will learn it, but right now if you learn it, it's also still okay. This is the engineering arrow graph. Okay, so first you draw the horizontal line with your scale and only do this arrow mark freehand. It's okay. Clear? Any other questions, please? For the exercise, yes. Don't worry. Right now, I will check only your views. Then later, from next class onwards, I might check the other lines and all. Right now, the lines, if you draw, it's okay, no problem. Only I am worried about your the views that you do it. Any other questions, please? Muhammad Abdul Khalik Abdullah Yahya. Why this guy is a cheater? He attended the first hour, and after 7:30, I think he has gone. Anyway, and I'm happy Abdullah Majid Ubaidullah Al Qurairi is here today, and he is present all the classes. So I'm giving present anyway. But I put a yellow mark because there I'm going to check him until the last class how his uh, attendance will be. So I put it here. Abdullah, you're here, right? So just check. I gave you attendance, and I'm going to check only you from until the last class. If you are regular, don't worry. I will give you very good grades. Give you even some bonus marks. Don't worry. Right now, attend all the classes regularly and try to do all the exercises. You will be all right. Okay. That's why I'm just keeping the yellow just to check you if you are following the classes regularly or not. So don't worry. Later I will change the color to green. Okay. But Muhammad Abdul Khalik Abdullah Yahya, I am very, very disappointed with this boy, with this guy. He just left in the middle of the class and tried to cheat. That is, I think that is very bad. If you don't attend the class, since it's a virtual class, I cannot see you. Cheat yourself. You cheat yourself actually. If you miss the class, then you cannot draw this. You'll be losing your marks. You know that. Don't try to cheat me. You're not cheating me, you're cheating yourself. Now how much effort I'm making to continue the class for 3 hours, and we do so many. This is a very difficult class actually, because engineering drawing is a skill development. So you have to use your hands. It's like a skill. So you have to improve your skill. If you miss the class, it's very difficult actually. Cool. Okay. Hope it should be all right. So let this Yahya guy to know that today he's absent. All right. Okay. Any more questions? Let me see some more questions here. Yes. Please go on. The height is 80. Yeah, I think so. The height is 80. Yes. 40 plus 40, 80. Yes. See here. Yes, 80 is given. See. The height is 80. Of course. Yes. The length is 100. Sorry, the width is 100. The length is 60. Yep. So, doctor, we have a whole week for the homework. Yeah. Next class. Your whole week. But I'm going to send you one more exercise, by the way. You know that, right? So today's exercise and one more exercise you have to do and bring it by next class. I will give you maybe 48 hours. Maybe how many hours you need? Not 1 week. Maybe 3 days. 72 hours. Is that okay? All of you? I might give you 72 hours, not 48 hours, because I know this is a difficult task. So even 72 hours to submit it. All right, everyone. Okay, I'm very happy today we have completed the most important part of the engineering drawing class. And I hope everyone at least knows some. Please check with your friends. So recorded message here, recorded lecture here. Yeah, homework details. I'm going to upload it. Yes. Not today, maybe tomorrow. Because today I don't know. I will inform you through email. Then I'll give you 72 hours from the time of the exercise. When you finish this exercise and the other one and submit it within 72 hours, and it'll be all right. You have to submit to the Blackboard. Yes. The degree is, I think, 4 grades maybe. Each view, I'll give you 0.5 marks. So it'll be 1.5 plus 1.5, 3 grades maybe. Yeah. 3 grades. Okay. If I give you 2 more exercise, it'll be 4 grades. Don't worry. Or 4 or 5 grades. Okay. Good. All right. All right. All right. Me read. What do you see? Mead. What do you mean by mead? Okay, thank you. All right, all right. Yeah, right. Mid. Okay, mid semester. Don't worry now. Mid semester is what you are doing now. This is the same thing you're going to do in the mid semester exam. So if you do these exercises good, then your midterm is just cake walk. I'm sure you have already done your midterm exam, because this is what I'm going to ask in your midterm exam. I'm going to give you one 3-dimensional view, and you have to draw the multi-view drawing: front view, top view, and side view. Only difference is the midterm exam you have to finish it within 3 hours. 3 hours, and maybe the exercise will be a little difficult one, maybe with circle and semicircle, so it will be a little difficult. But you are going to get within 3 hours. You're going to get 20 grades. So mid is going to be very easy for you. So just the same question mostly with a different. By the way, yes. Don't worry about midterm. Now you learned the midterm now. That's what you're doing now. Okay, yeah. Very nice. Any other questions, please? Oh, great. Okay, then, all of you except this Yahya guy who cheated, just inform him. And for the rest of you, please continue your exercise and submit it. Once the next exercise is, the assignment is sent through email, then you submit both together to the blackboard, and you will get the grades for this exercise as well. Oh, you did the exercise. That's very nice. That's very nice. What's your name? What's your name and number? I believe in you. Good guy. Can you put your number, please? 204409. Who is this guy? 204409. Abdul Rahman Muhammad Atala Alanzi. Very nice. Great. I will give you one bonus here. Great going. You'll get a bonus. Okay. Abdul Rahman Muhammad Atala Alanzi. Great. All right. Okay, then, guys, please. Yeah. Me too. I finished. Who is this guy? Put the number, please. These people are very good. Within 1 hour, they finished. Huh? What's your number, please? 994. Okay. You stop here. That's it. No. Don't put the numbers, please, guys. I think I have to stop now. Yeah. I think your time is up. Only 3 of you. That's it. Don't tell me, huh? 994 260. Let me check. 4. Let's see. 994 Ziyad Abdul Salam Hamadi. Classes. Okay, this guy is good. 4.255, 3.5. Okay, I think this guy is also good. Al Jadani. 1 bonus. And what about the other guy? What's this number? 260. 260. Let's see 260. Where's 260? Here is Osama Naif Habib Ala Al Salma Al Percent. 4.7553. Okay, this guy is also good. Bonus. Okay, very nice. Excellent. These people are very good because they attend all the classes and see their marks. They are already got good marks, so I believe these people must have done. I think we can stop here. Dr. Sand the X. No problem. I believe in you guys. I know. I can see that. I have seen your history. You are good. Okay. Thank you very much, everyone. We'll meet on the next class, same time. Until from all of you from here, a very good night, and we'll meet on next class. This class is dismissed. Thank you very much, everyone, for the cooperation. Bye-bye. Have a good night.